Ladies and gentlemen, today is the greatest day of them all. It is Wednesday, the greatest day of the entire week, because once it's done, you feel like your week is almost over. Because then there's a Thursday, which is a great day because it's the day before Friday, and then there's Friday, which you know when it's done, your weekend is there. So it's better than Monday and Tuesday for sure. I think Wednesday might be my favorite day of the year, of the week, excuse me. So we have our first question in our practice test here for Chapter 8. It says, what is the solution to the equation? So the easiest way, there's multiple ways to do this, but we're going to keep it simple. Constant, coefficient, variable, equivalent value. Oh, that's not the equivalent values. Once we have that written, we're going to treat it just like we would if it was 2 minus 4x equals negative 3. If it was this question, we would subtract 2 from both sides, correct? And then we would divide both sides by 4. So here, we're going to subtract the constant, which is 1/3, to get rid of it, leaving me with negative 3 over 2x equals. Subtracting a third here means I need a common denominator. The common denominator will be 6. The equivalent fraction is 2. Subtract the numerators, keep the denominator. Negative 1 take away 2 is negative 3. So negative 3/6 is the solution to when I remove a third from both sides. Divide both sides by the coefficient. But dividing by a fraction, the easiest way to do it, we've practiced it 1,000 times now, is to multiply by the reciprocal. And notice I kept my negative sign in the numerator. It doesn't really matter, but it's always good form. X is isolated. The answer is positive 6/18, which if I reduce it to lowest terms, because both are divisible by 6, I get 1/3 as my solution. Now, there might be some people that say, well, I'm going to take this and I'm going to rewrite it like this. So I rewrote this term as 3x over 2, right? If you did that, the luxury it affords you is you can multiply both sides by 6. And because this is a binomial, 1/3 times 6 is 2. 3x over 2 is going to be 9x, when you multiply that out, cross produce, equals negative 1. So simply by multiplying both sides by 6, you avoid the cumbersome fraction problem, and you end up with a much easier, minus 2 minus 2. Negative 9x equals negative 3. Divide both sides by negative 9, and x equals 3/9, which in lowest terms is still 1/3. So depending on what you did, either way you did it, you got 1/3 as your solution. Question 2 is section 1 question, 8.1. The variables in our denominator, which is an unlikely place for a variable. So our solution is to simply multiply both sides by t to get it out of the denominator. We end up with negative 5.2 over here is equal to negative 3.2t. Now we're going to divide both sides by the coefficient. T is isolated. And our solution to 5.2 divided by 3.25 is 1.6. So therefore, your solution is A. T equals a positive 1.6. Question 3, variables on both sides, which is at 8.4 chapter thing. So we're going to rewrite it here. Constant, coefficient, constant, coefficient. Since we have variables on both sides, we agreed that we need to get rid of it on one side. Doesn't matter which one we do. But we did say that if you get rid of it on the side that has the least amount, you're more than likely going to keep it as a positive coefficient. So the least amount of g is negative 0.3. So I'm simply going to add 0.3g to both sides. That creates a zero pair. I get 0.45 is equal to 0.85. Plus, remember, these are like terms. When you add like terms, you keep the term and add or combine the coefficients. So you'd end up with a half a g, right? That's from chapter 5 on polynomials, gathering like terms. Subtract your constant from both sides. 0.4 negative is equal to 0.45 or 0.5g. I'm having a hard time with my big boy words today. Now, without grabbing a calculator, I am dividing by a half here, right? I'm dividing by a half, which is dividing by half. And with fractions, we said when you divide by half, it's the same thing as multiplying by the reciprocal. So instead of grabbing a calculator, you can actually do negative 0.4 divided by half because you just have to double it. So it's negative 0.8 equals g. Now, if you don't believe me, just grab a calculator, double check it. 0.4 divided by a half, same thing as multiplying by 2. It is doubling it decimally. So your solution is B, negative 0.8. Our final multiple choice is which equation does not have the solution y equals negative 2. What you could do is solve all of these and figure out which one does not have the solution of y equals negative 2. But a better way is to simply take the expression that has the variable, and substitute negative 2 for the y. So this is going to be a negative half plus 1, and a negative half plus 1 is a half. If that equals the other side, which it does, then the solution for y equals 2 is correct. Y equals negative 2. So in this one, y does equal negative 2, and we're looking for does not equal negative 2. So A is not the answer. In B, take this expression, 7 over 8 minus 1, and then the y we're going to substitute for negative 2. We're going to get a common denominator. Now notice how the negative sign is in my denominator. It's okay to switch it right away. It's okay to do that. That's still a negative half. That's still okay. Common denominator will be 8. Your equivalent fraction will be negative 4/8. Now that you have it written like that, notice how important it is to keep that negative sign in the numerator. Keep your denominator and subtract your numerators. Subtracting is easier to add the opposite. I end up with 11/8 as a solution, which is equal to 1 and 3/8, which is the other side. So because when I worked out this expression, with y being negative 2, it came out to be this. And for b, y is equal to negative 2. So we're still no farther ahead. We've worked it out. We know that a and b both have variable values that are equal to negative 2. We're hoping that c is it, because if it's not, then we have to keep going. So here we have variables on both sides. So 2 multiplied by the value of y, minus 1 divided by 4. And we have another one of 5y minus 4, which is going to become 5 times negative 2 minus 4 divided by 8. Now, if these two expressions are equal, then we know that y is equal to negative 2, because we substitute negative 2 for both. Could use BEDMAS, so I got negative 10 minus 4 over 8, which is key flip change. It's negative 14 over 8, which is negative 1 and 6/8, which is equal to negative 1 and 3/4. So when I work that out, using BEDMAS sense, this expression, when y is equal to negative 2, has a value of 1 and 3/4. Now, if the other one equals 1 and 3/4, we're off to the races. 2 times negative 2 is negative 4. Negative 4 take away 1 is negative 5. Negative 5 divided by 4 is negative 1 1/4. So in C, the y values, when substituted for negative 2, they don't equal each other, which means that this is the one that does not have a y value of negative 2, because if it did, both of those expressions would be the same. Right? So our answer for this one is C, and that's our proof. Question 5, to solve a linear equation, you isolate the variable. Question 6, for 2.43 equals negative 0.38v, the solution expressed in the nearest hundredth is v equals something. So we're going to solve it by dividing both sides by this. When I grab my calculator, 2.43 divided by 0.38 equals a big long, where does the repeating decimal start? Where's 39 at? Oh boy, not for a while, eh? don't even think it has it there, does it? Huh. I don't even see the repeating pattern. So what ends up happening here, we need to round it to the nearest hundredths position. That's the tenths, the hundredths position, so 6.39. Since the thousandths is 4, we keep it as 0.69, so we say is approximately 6.39 to the nearest hundredth. And we use those wavy lines to say is approximately. You could also use an equal sign with a dot above it. Oh, approximately 6.39. Question 8, describe the steps you would use to solve this equation. So for 8a, the first thing I would do, step 1, is expand using distributive property. I would expand this side, and I would expand this side. Step 2, I would have variables on both sides. I would isolate variable to one side. Right? And you could say it differently, but you know what I mean by that. Once I have that, solve normally. And what that means is get rid of your constant first, then get rid of your coefficient. Okay. For B, what would the steps be different for this one? Well, for this one, we have eliminated the need to expand using distributive property. It's already expanded for us. So we would just pick it up right here, isolate the variable on one side. I would, for that question, I would subtract a half an x from both sides, etc., etc. Question 9 says solve and check. Since we have multiple fractions, what I'm going to do is multiply by the first common multiple both have. So I'm going to multiply this side by 10, and I'm going to multiply this side by 10, keeping them equivalent. We know that if we multiply this side by 10 and multiply this by 10, we maintain equality. Cross reduction. Padme had a revelation, in her head, and she understands it now. It's brilliant. So when I cross reduce, I get a 5. So I'm going to multiply 5 by a plus 1, which is going to give me 5a plus 5. So when I multiply half of a plus 1 by 10, I get 5a plus 5. It makes sense. When I multiply a fifth of 2a minus 1, I'm going to end up with 4a minus 2 when I expand using distributive property. 2 multiplied by 2a minus 1. Once we have that, I'm going to have variables on both sides. I'm going to get rid of the 4a by subtracting 4a from both sides. A plus 5 equals negative 2. Get rid of the constant. And final answer is a equals negative 7. Question 10, we have a fairly simple. Oh, did I skip a question back there? I did, didn't I? I forgot B. Expand using distributive property first. 2.8 times 3 is 6. 8.4. 8.4d minus 2.8 times 2 is 5.6 equals negative 12.32. We have a simple question now. Add the constant to both sides to get rid of it. 8.4d equals, oh, that's not the right one. No. Nope. Panic. Let's try this again. 12.32, I'm going to make that a negative. Plus 5.6 equals negative 6.72. Divide that by the coefficient of 8.4. Divide that by 8.4. And the solution is d equals negative 0.8. Question 10, express our answer to the nearest tenth. So here when we isolate the variable, it's going to be a longer than a terminating decimal. It'll be a repeating decimal. In such cases, it's always best to round your answer so you approximate the value of x. Subtract the constant from both sides. Oh, sorry, that's not right. Sorry, that's not even close to right. I have variables on both sides. Now here's an interesting dilemma. If I add 13.9 to both sides, x. If I do that, no problem. The only problem is it becomes 0 on this side. And that's going to be 1.4, a positive 1.4x. No problem. Just an extra step. I made my work a little bit harder. Subtract 5.7 from both sides. You get a negative 5.7 equals 1.4x when you remove 5.7 from both sides. When you divide both sides by 1.4, 5.7 divided by 1.4 should be a long decimal, and it is. The question says round it to the nearest tenth. So what's our answer going to be? Approximately 4.1, correct? So we say x is approximately equal to 4.1 because we rounded it. Second time, we have expansion using distributive property, doubling. Shoot. I'm going to expand using distributive property. Doubling 1.8 would be 1.6s plus 2.4 equals negative 3s plus 1.2. So when I expand using distributive property, I get that. I'm going to add 3s to both sides. 4.6s plus 2.4 equals 1.2. I'm going to subtract 2.4 from both sides. I get 4.6s equals negative 1.2. I'm going to divide both sides by 4.6. So negative 1.2 divided by 4.6 equals, keeping that to the nearest tenth, what's my answer going to be? Approximately negative 0.3. So s equals approximately negative 0.3. Thank you. Now we get into our story problems. Precipitation is moisture that falls in the form of rain or snow. There you go. New learning science class. Who knew? The relationship between the depth of rain, symbolized by the variable r, and the depth of snow, symbolized by the variable s. The results equal quantities of precipitation is the amount of rain divided by the amount of snow will equal 0.1. So if I use this formula, and I read the question, if a storm delivers 15.5 centimeters of snow, what depth of rain would result? So what I'm going to do here is I'm going to substitute my snow for the quantity it says, in this case 15.5, and I'm going to solve it using my algebra sense. So 15.5, multiply both sides by 15.5. R would therefore equal 1.55. So therefore, the amount of rain would be 1.55 centimeters. If there was 15.5 centimeters of snow, the same amount of rain necessary to make that much snow would only be 1.55 centimeters. Of course, we know that that amount of rain would expand with crystallization. In B, take the same formula, R divided by S equals 0.1, but this time we're given the amount of rain, 2.7. So I'm going to substitute my 2.7 for here. And as we now know from experience, because the variable's in the denominator, it's a two-step equation. We're going to multiply both sides by S. 2.7 equals 0.1s. Divide by the coefficient of 0.1. Now remember, dividing by a tenth is the same thing as multiplying by the reciprocal, right? So dividing by a tenth is the same thing. Don't grab your calculator because dividing by a tenth should be easy to do. What's 2.7 divided by a tenth then, if it's the same thing as multiplying by 10? Just 27, right? Move the decimal one place over. So therefore, 2.7 centimeters of rain would equal 27 centimeters of snow. Question 12, Nav is working part-time. She pays a monthly fee of $5.95 for her bank account. So every month, regardless of how much she uses her bank, she's giving the bank $5.95 for the privilege of having a bank account. And with her bank, the bank charges her 75 cents for any time she makes a deposit or any time she makes a withdrawal. 1 month, she had to pay the bank, and the total cost of her account was $12.70. How many deposits or withdrawals did she make? So the first thing we know with story problems is we have to define their variable. And since our question says how many deposits or withdrawals did she make, our definition of the variable x will equal the number of withdrawals or deposits, right? Mito, how much did each withdrawal or deposit cost, according to the information that we're given? 75 cents, right? So what would you do with X being the number of times you withdrew or deposits if each of them is going to cost you 75 cents? Are you going to add 75 cents to X, or are you going to multiply 75 cents by X? Multiply, right? So 0.75 multiplied by the number of withdrawals or deposits will be the amount of money spent on that particular aspect. Plus, regardless of how many withdrawals or deposits were made, there's a straight up fee of $5.95, which in this case represents your constant. That totaled $12.70. So that's step 2, is make your equation. Then if we solve it by subtracting $5.95 from both sides, if I subtract $5.95 from both sides, what is $12.70? $12.70 take away $5.95. It's $6.75. How many 75 cents are in $1.50? How many in $3? How many in $6? How many in $6.75? No, one more. You went the wrong way. 9. So if we work it out that way, $6.75 divided by 75 cents equals 9. So therefore, that's our solution. So step 1, define your variable. Step 2, make an equation. Step 3, solve your equation. Step 4, therefore, the number of withdrawals or deposits was 9 that month. Question 13. Ooh, I love these ones. These are the 2 variables questions. 2 computer technicians both charge a fee for a home visit, plus an hourly rate for their work. So Dana will charge you $64.95 for showing up at your door. So if you call him to come over and he works 0 hours, he's still charging you $64.95 for knocking on your door. But if he spends any type amount of time, he's charging you $45 an hour on top of that. So for Dana, that's his. For Tom, he charges you a service fee of $79.95. So it's more expensive for Tom to come to your door, but he charges less per hour, $40 per hour. For what length of a service call do Dana and Tom charge the same amount? So our first thing is to find the variable. Since we're looking for the length of a service call, X is going to be the number of hours worked. That's the length of a service call, right? For Dana, it's $64.95 plus $45 an hour. So 45 multiplied by the number of hours that he works. That's how much Dana will charge you for showing up at your door. Tom, on the other hand, charges you a slightly larger initial fee, but it will be less per hour. So if we think about this as a scale, if it's 0 hours worked, 0 hours worked, Tom will charge you more money, right? But eventually, depending on the number of hours, because he charges you less per hour, there is a moment at which these 2 sides are going to be equal. And therefore, the equation we can make is $64.95 plus 45x, that's Dana's, must be equal to $79.95 plus 40x, when x has a shared common value where both sides are now made equal. Does that make sense? There is a value for x in which both of those will be equal. We're going to figure that out now. Subtract 40x from both sides, correct? We'll have $64.95 plus 5x equals $79.95. That's if I remove 40x from both sides. If I remove $64.95 from both sides, I end up with 5x equals 15. That's just removing $64.95 from both sides. And if I divide both sides by 5, I get the solution of x equals 3. So therefore, after 3 hours, both make, or both cost, excuse me, not both make. They actually, in their own pockets, they would. They cost the same. So Tom will cost you more for 1 hour, 2 hours. But after that, 3 hours will cost the same. But 4 hours, 5 hours, 6 hours, 7 hours, 8 hours, your best bet is to go with Dan because he charges you less per hour. Okay, you'll recuperate the extra part of your service call fee. Question 14, we have our perimeter question. So this is the side length, and there's 4 of them. That's the perimeter. So perimeter will equal 4 multiplied by the side length. Since this perimeter is actually algebraically speaking, it's 4 of the 2Ds plus 3.1. That will equal the perimeter of the square. Since this is a pentagon or a 5-sided equal-sided figure, the formula for the perimeter of this one will be 5s equals the perimeter, or 5 multiplied by the side length. That's the perimeter of the pentagon. It does say in the instruction that the square and the regular pentagon have equal perimeters. So therefore, the perimeter of the square is equal to the perimeter of the pentagon. Once we create our equation, what's the first step we need to do here? Expand using distributive property, correct? We'll have 8d minus 12.4 equals 7 minus 10d, I think. All right, if we expand that using distributive property. Avery, even though you haven't been here for 6.5 years, do you have any idea what you would do first here? No clue. Emma knows. Emma, what would you do? Right, we're going to get the least amount God. You don't have to. You could subtract 8d, and it ain't no thing. But the nice thing about getting rid of the least amount of d is you end up with a positive amount of d for a coefficient, which is the only benefit of doing it that way. Once we add 12.4 to both sides, we have 18d equals 19.4. Agreed? Take our 19.4 and divide it by the coefficient of 18. Uh-oh, I made a mistake somewhere, didn't I? 12.4. I made a mistake right here. It's supposed to be a positive, isn't it? Right? Oops. So when I subtract 12.4 from both sides, thank you, 7 take away 12.4, not add 12.4, equals negative 5.4. There's where I made my mistake. See, didn't copy the question down right. Once I do that, divide both sides by 18, and a negative 5.4 divided by 18 equals negative 0.3. So d equals negative 0.3. Now, if this question's on your test, you're not done yet, because the algebraic perimeter is that. But the actual length, since d equals negative 0.3, I have to substitute it in. There we go. So when I substitute d for negative 0.3 and work it out using BEDMAS, this expression here, when d is negative 0.3, is actually equal to 2.5. So this is 2.5, this is 2.5, this is 2.5, this is 2.5. So the perimeter of that square is actually 10. Guess what the perimeter of the pentagon is without working it out? It's actually 10 as well. This should be 2, 2, 2, 2, and 2 because they have equal perimeters, correct? So this should equal, when I substitute negative 0.2 for my d here, negative 0.3, that should equal positive 2 because they have equal perimeters. 1.4 takeaway, this is going to work out to be take away Negative 0.6. Keep, flip, change. Guess what that is? It's a positive 2. So therefore, the perimeter of this is also 10. Our last question, 15, says identify the error. So let's see what this person did. So they first expanded, it appears, by distributive property. Uh-oh. You see it right away? Where did they not, where did they go wrong? They didn't expand fully. They left, they didn't multiply 3 by negative 3.1. They just multiplied 2. And that's where they made the mistake. So if you corrected their error, this next line should be 6.2n minus 9.3 equals 12.3. Add 9.3 to both sides. 21.3, 21.6. Divide by 6.2. 21.6 divided by 6.2 equals, oh, I made a mistake again. Where did I make a mistake? Oops, it does say round your answer to the nearest tenth. So to the nearest tenth, our approximate answer would therefore be approximately n equals negative 3.5, approximately equals.